What's up, YouTube? Back at it again with another project, and this one took some time. It's an LED matrix that I built with custom PCB boards that I actually ordered and designed myself. If you guys want link for the boards to order them yourselves, I'll put that in there. Just let me know. But yeah, this took 20 hours of just soldering alone to get it done. So stay tuned and I'll show you the whole project. Thanks for watching. First things first, got to give a shout out to PCBWay, because if it wasn't for them reaching out to me for a project or sponsoring a project, probably would have never done a custom PCB board. But fun to design and make it. They actually helped me with some of the challenging parts of figuring out what was wrong with my board. The boards actually shipped out probably 2 days after they were manufactured, and I got them in probably 3 days. So it took about 5 days to get these boards, and quite frankly, they turned out beautiful. The traces are good. I probably went a little overboard with the traces, but you know, I didn't know how many amps this was going to pull, so I went along with it, and it turned out great. These boards use the WS2812B LED, and I purchased 1,000 of them online. I think it was about $90. And I still have some left over, so I'm not really stressing it too much about future projects, so to speak. I think this project used about 320 LEDs in total, and trust me, every one of them had to be soldered on there, and it was quite an experience. I got to learn how to use the paste. I got to learn how to set it up, and you got to orient the LEDs a certain way, so you had to make sure that you were paying attention as you were putting each one on here. And a couple times I messed up, which I wasn't really stressing too much, but I found out real quick when I connected it all together that some of them didn't work, and when some of them didn't work, obviously it didn't connect to the next one. So you know, these are addressable LEDs, so they have to communicate with each other along the entire line. So if one doesn't work, the rest of the line doesn't work. I originally started getting these things out one by one, and then I realized that I just dumped a whole bunch of them on my desk. I was real worried about damaging them with the tweezers. Come to find out, these things are really, really tough. Packaging kind of scares you, and so does the data sheet when you look at it, when you go to look these things up, and it tells you, you know, be careful setting them, you don't use too much heat. But my experience with these little LEDs, they're pretty resilient, and they take a lot of heat. And quite frankly, when you're soldering on there, you're going to use a decent amount of heat just to get them to solder onto the board. So putting the paste and setting LEDs is what really took the most time on these boards. And quite frankly, this is kind of the funnest part, along with wiring it up. But yeah, it was satisfying in the end when I hooked everything up, you know, after, you know, fixing a couple that didn't work. But once it was all said and done and it worked, it was very satisfying. So a new tool that I actually added to the arsenal was this solder rework station I got off of Amazon, and this thing actually saved the day, because if I had to solder this with a regular soldering iron, oh boy, I would still be doing it, and this video still would be in process. It did take some time. You have to heat up each one of them, but you can visually see each little LED set in its place and every little ball of solder, and it's very, very satisfying to do. But you still have to do it one by one. You can't just go and heat the whole board up, and which I wish I'd gotten a hot plate in a way, because come to find out, the dimensions of this board fit a hot plate that I saw on Amazon perfectly. But this was after I did this, yeah, when I went to go look it up, and I was quite disappointed in myself. So I could have got the hot plate, and this thing would have been done a heck of a lot sooner. But also, I wouldn't have had the fun of soldering all on there. I designed this board with power and ground ports as through holes, so I could solder wiring on the back side of the boards, and on the front side I can just put jumpers. Basically, I designed it with pads all the way down the edge of it for power and ground, but I didn't need it all. I just needed one. One board alone by itself only pulls, I think, 400 milliamps at its highest, and you can kind of limit that with the software. So I even limited it down even lower than that when I went to go add the software to it. But with the next board, I think I'll design it with just 2 pads, maybe a little bit larger, just to be on the safe side, just in case I have to run a long string. Here I found a old shelf from one of my old cabinets that we ended up throwing away, so I saved a couple of the shelves, and it came in handy with this project. It gave me a place to mount this and mount it on the wall, and quite frankly, it looks pretty good with the blue, in my opinion. How I ended up mounting all this on this board was some really strong double-sided tape, 3M, and I think it's about 1/4 of an inch wide, and it holds on there. I can lift the whole thing from both sides, and it can shake it and it doesn't come unglued. So here are the jumpers for the power and grounds on the top and bottom edges that I was telling you guys about. So you'll see there's little pads that go all the way down for each runner, each row of LEDs. Like I said, I didn't need all of these. All I needed was one, and it works great. None of the wires are overheated by any means. It's the amperage, it can handle the amperage all day. And I've ran this thing, I think since that's been done, I ran it for like 2 days, and it never got hot. So there's no high resistance anywhere. I designed this so it'd be easy to put together once I got it. And quite frankly, there's a couple of things I probably would change to make it even easier. I'd like to make it so it just clips together with connectors instead of jumper wires to make it cleaner. But being the first time me building anything or designing a PCB board, I try to keep it a little simple. The controller I used is a ESP32 board. This was the cheapest one I could find on Amazon, which is probably not the best route, but the only 2 connections I actually had to make were power and ground and pin 16, so the GPIO pin for the software, because that's what they designate for the data line for the software. And the software I use is the WLED library, I don't know what they would call it, but this is what I ended up using. I found a couple of tutorials online on how to use this, and if you guys want to use it, that's probably your best route, or I can show you. Just let me know in the comments. But this installs, if they say it takes 3 minutes, and it did. It only took 3 minutes, and I had my matrix working pretty quick. And as a matter of fact, the software helps you set up the grid that you need as well. So when you do it, it doesn't take as much time as you would think in order to get this thing running. And then they have so many different things you can run on this already preloaded into the software. Here are some examples, and you can see where the matrix wasn't working all the way down the line, and come to find out one of the LEDs wasn't soldered all the way down. So I kind of had to go, like the first 3 went together pretty well and didn't have any issues, but I also, when I did those, I checked them, hooked them up and checked them as I went. The last 2 I did not. So you can see, okay, I need to go and resolder a couple of the LEDs. So you'll see here now, it's me messing around with it. So I put a little ball solder, and then next thing you know it, the next set starts to work, and then, yeah. So I had to keep going along the line in order to get it to work. The colors with these LEDs are very vibrant. Kind of the reason why I went with them is that I've used them on other projects that I've had, and quite frankly, I wanted to make a matrix with it. And the examples here, the camera doesn't do it very good justice, but in person, this thing is very beautiful. And I noticed my spacing in between the boards is a little thick, but when it's on, you can kind of see it. But to me, it really doesn't affect the the look and the feel of it, so it really doesn't hurt my feelings that I have that little gap in between it. At first I thought I was going to overlap the boards to kind of get rid of the gap, but nah, I just left it as it is. I think when I redesign it, if I redesign it, I'll give it less of a gap so that you don't actually visually see the gap anymore. But I think my next project's probably going to do the whole wall, and I'll redesign it so that everything is evenly spaced, even if the boards are together in the matrix. All in all, this project was really fun. It did take me a little while to get everything soldered on there, but I think the fruit of my labor was definitely profitable because this thing looks great, especially in a very dark room. And I honestly don't have the brightness all the way up. I could turn it up, and for the camera I had to turn it down, so this is probably like 20%, and it looks pretty good. But if you guys like this project, I'm planning on doing many more, so stay tuned for the next one. I think the next one's going to be an LED matrix that covers the entire wall that this is attached to right here. So stay tuned, like and subscribe. See you later.
So high I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.